This video is about the moon, but to understand the essence, you need to know some things about the sun. And I will ask you a question. How do you think can sun shine for days and not set? It can. There are days and nights when Earth is under the sunshine, it's bright. When Earth is in its own shade, it's dark. But since Earth inclines, the length of day changes. Due to the inclination, in transpolar you can see polar days when the sun does not go under the horizon for days, and polar nights when the sun does not come out of the horizon for days. This is why it is transpolar, and then closer you are to the pole, then longer polar days and nights are. But there's another notable place on Earth. You likely heard the phrase, the sun is in zenith. It usually means that the sun is at the highest point for today. But what zenith is? Zenith is the direction which is opposite to the direction of gravity. So phrase sun in zenith properly means that the sun is perpendicular to the earth, or saying with simple words, just overhead. In tropics, the sun can reach the zenith and shine so that things will throw shadows straight under themselves. This is why they are tropics. But where are tropics and transpolar situated? Transpolar is a pole and adjoining territories. It's bordered with polar circle, which means to be the border of polar day at summer solstice and polar night at winter solstice. Tropics are the equator and adjoining territories. They are bordered with two tropics. During a year, the sun is shifting from one tropic to the other, and within tropics, the sun can reach the zenith 2 times a year, while on the tropics themselves, the sun reaches the zenith only at the summer solstice. Equator and poles are opposed to each other. Poles are the highest and the lowest dots of a planet. Equator is the middle of a planet that's dividing it for 2 hemispheres. It's equidistant from both poles. It's possible to say that equator is the midway between 2 poles. But how to locate some place which is indicated between the equator and a pole? With the help of parallels. Parallels are lines on the map that stretches from the west to the east, or backwards. They mean to locate some place at the map. On 3-dimensional models, parallels are circles, and then closer they are to a pole, then narrower they are, and the pole itself is not a circle, but just a dot. Equator is the 0th parallel, poles are 90th parallels, and the rest of parallels are in between. In particular, the tropics are 23rd parallels and polar circles are 66th parallels. But inclination of Earth is not permanent. It's changing year by year, so tropics and polar circles are shifting, which can be shown at some road. At different times, tropics can be anywhere between 22nd and 24th parallels. Polar circles can be anywhere between 65th and 67th parallels. Equator and poles are motionless. Now tropics are shifting towards the equator, while polar circles are shifting towards the poles. At least it's written so in the internet. Now we can discuss the moon. Once I asked myself if moon can be seen in zenith, and if yes, then where? I typed moon in zenith in my native language in search engine, and I found only some series. Then I typed it in this language, and I found some forum where someone asked the same question. So someone left 2 links here and described them. Here, let us see them. First link, well, here is just day and night. Well, this is day, this is night. This is the border of polar night. This is the border of polar day. This is where's the sun in zenith. This is what's time now. Well, now let's go by the other link. The other link here, you can see this is the place where the moon is in zenith. A bit higher, someone writes that the moon can reach the zenith anywhere between latitude 28.5 north and south. The Earth 23.5 tilt plus the 5 degrees inclination of the moon's orbit between 18.5 north and south. The moon will reach very close to the zenith every month, but as you go further from the equator, you'll get longer and longer periods when the moon doesn't reach the zenith. At 28.5 degrees latitude, you will get 18-year gaps. So 23rd parallel is the sun or solar tropic. I don't know what adjective to use, and the 28th parallel is moon tropic. If tropics are shifting towards the equator, then polar circles are shifting towards poles. If tropics are shifting to the opposite side from the equator, then polar circles are shifting to the opposite side from poles. Moon tropic is further from the equator for 5 parallels, so moon polar circle must be further from pole for 5 parallels at 61st parallel. It means that moon must run circle for days beyond 61st parallel sometimes. You can see moon in zenith every month on distance up to 18 parallels away from the equator, but then further you are from the equator, then less and less often you gotta see moon there, and at 28th parallel you gotta see there only once 18 years. Judging analogously to that, you can see moon polar day every month on distance up to 18 parallels away from a pole. Pole is 90th parallel, so 90 minus 18 is 72. You can see moon polar day every month beyond 72nd parallel, but then further you are from a pole, then less and less often you gotta see moon polar days, and at 61st parallel you gotta see it only once 18 years. Moon has phases. It gets bigger and smaller. During a hypothetical polar day, it must be seen from a single place that moon is growing and growing up to full moon and getting smaller and smaller up to full absence of the moon. I'm not stranger to that topic. It's a question for me if it is possible to see moon polar days right here. I am at 64th parallel. Polar circle is 66th parallel and I am at 64th. Well, at winter the sun comes out for 4 hours at least, comes out somewhere here and coming like this. At summer the sun sets for at least 2 hours and, well, it's under the horizon somewhere there. It's bright enough so they don't turn on the lights and the clouds are reflecting the sunlight, but it's not polar day. 21:51. The moon is there now. I remember that moon was at the other side. Well, there, somewhere there, very high but still not in zenith. I remember it was there at 9 o'clock a.m. at p.m. at 7 o'clock a.m. I remember that moon was somewhere there 4 years ago at spring when there were white nights already. The color of the moon was something intermediate between yellow and white colors. But I don't remember that moon would be ever somewhere there. Maybe it's covered by trees and buildings. It is north there, and it's logical that moon must be below there. But, well, maybe moon can't be seen there because it's covered with something. Maybe it can't be seen because it's setting under the horizon. But there must be also moon polar nights, when the moon does not come out of the horizon for days. Once again, beyond 72nd parallel, it must be seen every month. But then further you are from a pole, then less and less often they must be seen. And it seems that they can be seen here. 10 or 11 months ago, I've been at this band dividing machine. Well, actually not at this one. There was the other one here, there with the green light. Not 2 weeks ago they swapped these two machines for some reason. Anyway, I was here and there was some moon there. Half of the moon, 9 o'clock a.m., nautical twilight, the moon was low. I don't remember exactly if the moon was there at 8 o'clock a.m. I remember for sure that there was no moon there at 10 o'clock. But that's just a random memory. Maybe the moon was just low, it was covered with buildings and trees. Maybe moon was in such a phase when it was fully shaded and I assumed that there's no moon. I assumed that it's a moon polar night. When the moon is under the horizon, it looks like it's nautical twilights. If moon twilight is possible, can moon light the sky being under the horizon? Polar night is when the sun is under the horizon for days, but it doesn't mean darkness around the clock. The sun is approaching to the horizon from above, so it's possible to see some kind of twilight during polar night. Moreover, it's possible to see pitch dark polar night only beyond 84th parallel. If you're not that close to a pole, then polar nights will be crepuscular. So I have a question. If it's possible, the moon would have approached to the horizon from above, so it would be able to light the atmosphere, but yet not rise. By the way, aforementioned analogy between a tropic and a polar circle is not very correct. Position of sun or moon in zenith is a short event that can be seen during one day. Well, length of polar day and polar night differs depending on how close you are to a pole, but it can be seen during more than one day. Also, there's refraction, when light can bypass some little hurdles on its way. Due to the refraction, we can see moon and sun when they rise and set near the horizon, despite they actually under the horizon. Due to the refraction, you can see polar days at some places at 65th parallel, despite it's not transpolary, and cannot see polar nights at 66th and partly 67th parallel, despite it is transpolary. Polar circle means to be the border of polar days and nights, but de facto it's the latitude where the half of the sun sticks out of the horizon at the brightest moment of winter solstice and darkest moment of summer solstice. Same thing with the moon. Moon polar nights must not be seen at 61st and partly 62nd parallel. Moon polar days must be seen partly at 60th parallel, while the refraction does not influence at the position of moon or sun in the zenith. They call territory between two sun tropics. I call territory beyond a sun polar circle transpolary. It's possible to call adjoining territories somehow. For example, it's possible to call the land between a sun and a moon tropic subtropics, and it's possible to call the land between moon and sun polar circles subpolary or circumpolary. But we know about 5 degrees moon's orbit inclination only from some commentary in the internet. How did he know that? Maybe his information is wrong. Anyway, no one seems to ask such questions in the internet. Maybe some physicist or geographist will see this video somehow and answer my questions.